Today we're going to start talking about some statistics and starting this new unit. We're going to start by talking about the difference between population and a sample and different types of sampling methods and that kind of thing when we talk about statistics. So, first things first, let's talk about where you've heard about statistics in life outside of the math classroom. So we have this little catch. Would you like to try a sample? So when you walk by places in the food court, of course, you hear that. Would you like to try a sample of this or try a sample of this? But this word sample in terms of statistics, you've probably heard a lot of times before something say, survey results show that 54% of Americans believe that da-da-da-da-da. And the thing behind that is that it doesn't actually mean that they asked every single American and that 54% of them said that they agreed with XYZ, but what they're able to do is they're able to get a random number of people that have contributed to their survey. And by doing that, through different methods of sampling, they're able to say that they have a pretty good consensus. As long as they've used a good sampling method, they're able to say they have a pretty good consensus that they believe 54% of Americans, if you really did ask all of them, would believe that da-da-da-da-da. So even though they don't necessarily ask every single American, the number of people that they do ask hopefully is random enough that they're able to get a pretty good idea of what the overall majority of Americans felt like. So that's the difference between a population and a sample, which we'll talk about more in just a second. But essentially, they're able to make conclusions about an entire group of people by just surveying a limited number of those people. So here are some definitions that I think are important and probably ones that you guys should write down. So maybe during this time of distance learning, you want to try to keep track of your notes and jotting things down, and maybe it's easiest for you to draw pictures, so maybe you want to try to do sketch notes. This lesson specifically is a great lesson to do pictures with. So if you want to try sketch notes and getting out colors and things like that, that might be a good idea. But at least jotting down the main ideas that we talk about today. So here are some definitions that you guys are going to hear throughout this lesson and then in the lessons to come in the statistics unit. So first things first, the difference between a population and a sample. So a population would be the entire group of people. You can see here, let's see if I can rotate this for us. You can see here in this infographic that this population would be the entire set of people. So whether or not that's the entire United States population or an entire class of students, etc., that's called the population. Everyone in the group that you're talking about. The sample, notice that it's a smaller number of people. So they just pulled a couple people here and there to be a part of their sample, and they asked them questions. And so they're trying to say that this is a representative group of all of these people that are up here. And last but not least, the thing that you're interested in finding out about those people is called the parameter of interest. So the population is the entire group, the sample is the selected number of people you've chosen from that group, and then the parameter of interest is what are you asking them, what are you even trying to figure out about these people in order to make conclusions about the entire group. So let's look at some examples. Here's an example. A grocery store wants to know the average number of items that shoppers purchase in each visit to the store. They decide to count the items in the cart of every 20th person through the check stand. So you've been to a grocery store, specifically right now, lots of people are going to grocery stores. And so they're trying to figure out the average number of items that each person has in their cart and that they're paying for as they go through the line. Now, obviously, it would take way too much time if you did it for every single customer, where you had to stop every single person and then count them, 1, 2, 3, 4, 5, 6, 7, etc., especially if you did it by hand. The computers could probably do it for them. But in this case, when we're doing it by hand, it would be a little excessive to do it with every single person. So what this scenario is saying is, why don't we do it for every 20th person? So let 19 people go through the check stand, and then on the 20th person, count the number of items in their cart. And essentially, if you did that for long enough, in enough stores, with enough different check stands, in enough different places, you could probably get a pretty good estimate of the average number of items that a person has in their cart that they're purchasing. So let's talk about these different definitions and what they mean for this example. Population. So the population would be the entire community of shoppers, everyone that goes to a grocery store. You saying hi? Mr. Martinez, wait for my video. There you go.
Hello, guys.
Wave to my video, Max. The population is the total number of shoppers that shop at a grocery store. The sample, all right, the second one, the sample. The sample in this situation would be the people that you actually surveyed. So every 20th person would be your sample from this example. So population is everyone that came to the grocery store. The sample would be every 20th person that went through the check stand. And the parameter of interest, this is again what we're trying to find out about these people. What we're trying to find out is how many items, the average number of items that each shopper has purchased in the visit. So that would be our parameter of interest, is how many items are you purchasing this visit? And then the next 20th person, we would ask that same question to. So that's what we're trying to find out. Let's look at another example. Example 2, a team of biologists wants to know the average weight of fish in a lake. They decide to drop a net and measure all the fish caught in 3 different locations in the lake. All right, population. The population would be the entire population of fish in the lake. Every single fish that lives in that lake would be the population. The sample. Notice it says they're only measuring the fish caught in these 3 different locations. So they dropped a net, they measured the fish's weight from 3 different locations in the lake, and then they only used those fish to give an average of all of the fish. So that would be the sample, the fish caught in those 3 different locations. And then the parameter of interest, again, we're trying to figure out how much each fish weighs on average. So that would be what we're interested in finding out. My example left me there. We'll have to come back to that one. I don't know where it went. All right. So here's some different sampling methods. Convenience sampling. Notice, by the way, at the bottom, it says that these 2 sampling methods create biased data. And you'll see why after we talk about it. So again, make sure you're jotting these down. These are the different types of sampling methods that are important in statistics. Convenient sampling. So convenient sampling is actually a perfect little picture so you guys can see an image of convenient sampling. But let's pretend that this little gray person in the middle is the surveyor. And notice that he's only talking to the people that are closest to him. That's because it's convenient for him. Hence why it's called convenience sampling. So essentially the surveyor just goes and talks to the people that are closest to them. It says it's probably the worst technique to use because the data is readily available. It's super easy to get the data, but it's also very biased because you're only talking to the people that are near you. And a lot of times the people that are near you are a lot like you. And so you're not getting a very good random population of people because you're only surveying the people that are closest to you, whether or not that's people that live around you or the friends you hang out with, etc., etc. So it is a type of sampling, just not a very good one. Volunteer sampling, the second one. Again, it creates biased data, and I don't know if any of you guys have ever experienced this before, but sometimes I'll get emails from different companies that are like, hey, participate in our survey. Thank you so much for coming into our store. Go ahead and fill out this survey about what you, like your experience when you were shopping. And I'm kind of busy. I don't really have time to fill out surveys all the time, so I don't always do it. But volunteer sampling really only gets the people that are invested in that. So the only time I've ever filled out one of those volunteer sampling surveys is if it's something I really care about and I really want them to know my opinion. Other than that, I wouldn't fill it out. So keeping that in mind, volunteer sampling only really works if you have a lot of people have a lot of buy-in. But since that's not always the case, you really only get the people that have that care enough about your survey to take it. And that's not a very good way to get the overall opinion of your population. So again, it says here, often these folks have a strong interest in the main topic of the survey. So notice the arrows in this one. So we have our surveyor, and notice the arrows are going the other way. They're going to the surveyor rather than the other way. So people are volunteering to take his survey, and he's not getting a very good response from the entire population that he's surveying. All right, we got 2 more right here, and there's a couple more after this as well. Simple random sampling. So simple random sampling is probably the purest form of probability sampling, meaning it's the best one. It is the best way to sample a population in order to get unbiased data because it really is random. Like it's just completely random how everyone was chosen. And you can see in this picture right here, it's not every other person, it's not every third person, it's just kind of a random selection of people that was not chosen ahead of time or biased for any reason. This method of sampling can be kind of difficult to execute because it is very difficult to actually so it can be hard to execute because simple random sampling requires that you have a list of information for the entire population. So if you're trying to perform a simple random sample on the people in the United States, you would need a list of every single person that lived in the United States, and then being able to reach every single one of them. So obviously that's kind of difficult to do. You can imagine that the bigger your population, the more difficult it is to perform a simple random sample. So even though it is the best way to sample, it's not always the most effective or efficient because it might take too long, it might be too much money to perform this kind of sample, etc., etc. We have systematic sampling. So systematic sampling is much easier to do than simple random sampling. And you can see here, a lot of times I'll do this in class sometimes with you guys, not necessarily the sampling piece of it, but this whole counting off idea. So notice you can kind of count people off, 1, 2, 3, 4, 1, 2, 3, 4. And I've done this with you guys in class. So you can see that every third person gets chosen. So starting with person number 2, every third person gets chosen. So here we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And we choose person number 2, and then 3 people later, we choose person number, 5, and then 3 people later, we choose person number 8, etc., etc. So you can see this example here that if you're numbering 1, 2, 3, 4, when you're all done numbering, you take everybody that was numbered number 4, and you get to use them for your survey. So systematic meaning that there's a system. So that I kind of like to remember that for the 1, 2, 3, 4 business. There's a system to your madness. Another type of sampling is stratified sampling. So this prefix strata is important. You may have heard it before in other contexts. So stratified sampling is possible when it makes sense to partition. Partition means to divide the population. When it means to partition the population into groups based on a specific factor. And again, these are called strata. So stratified sampling looks like this. You partition the population into groups. So you kind of divide them based on it could be based on certain qualities. So for example, you could divide the population based on ethnicity or based on gender or based on socioeconomic status, etc., etc. So you're dividing them into groups. And then it says you obtain a simple random sample from each group. So notice that they chose one person from this group and one person from this group and one person from this group and 2 people from this group. So you're trying to get a random number of people from each type of group to participate in your survey. And that's the simple random sampling from each group once you've divided them. Then we collect the data on each sampling unit that was randomly sampled from each group. So this ideally gives us a pretty varied, depending on how you separated the groups, it gives us a pretty varied sense of who's responding to the survey and what their opinions are. And they kind of ideally would be kind of representative of their group. And then we have cluster sampling. Now, cluster sampling and stratified sampling are very, very similar, but there's a slight difference. So in stratified sampling, we divide the population into groups, into strata, and then choose a couple people from each group, or however big the population is, choose maybe more than a couple. In cluster sampling, we also divide the population into groups, but the way that you sample is a little bit different. So cluster sampling is different because after you divide the population into groups or clusters, you obtain a simple random sample from a specific number of clusters. So here's what I mean by that. On the previous one, we chose a couple people from each group, from each strata. On this one, instead of choosing a couple people from each cluster, we're choosing the entire cluster. So you separate people based on these different qualifications or different characteristics, and then you sample everyone in the cluster at random. So you randomly choose clusters and sample everyone in that cluster. So that's a little different than stratified sampling. All right, so the last thing we'll do today is we'll look at some examples of this, and I want you guys to kind of follow along and maybe jot down some important points about the different types of sampling we look at. So it says there's lots of different ways that a sample can be chosen from a population. Classify the following example by which sampling method is being used. So for this one, example number 1, it says you are in charge of school activities. You want to know what activities students prefer to participate in during the school year. And by the way, the first 6 examples or so are all that same context. So the only thing that changes is how you're performing the sample, not the context of the problem. So in blue, it says you assign each student in the school a number. You randomly select a starting number among the first 10 numbers, and then select every 10th student in the list from that point forward. So for this one, here is a picture of all of those different types of samples we said. So you assign each student in the school a number. You randomly select a number among the first 10 numbers, and then select every 10th student in the list from that point forward. So that's an example of this one, systematic sample. Remember, this is the one where you would say 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and say every fourth person, you're going to take my survey. So that's what this is saying, randomly selecting a person starting with a random number, and then every 10th person after that. So there's a system to it, systematic. The next one, you're in charge of school activities. You want to know the activities students prefer to participate in during the school year. It says you make a lot of copies of the survey about the activities that students prefer, and you put them on a table. You put them on a table outside the cafeteria. Students can choose to take the survey and drop their responses into a big box on the table. So again, here's all the different types. This one is one of the biased ones. So notice that this is the one about a volunteer response sample. This is volunteer response sampling. The reason is because if you're just leaving the surveys there and there's really no buy-in for them to take it, you're randomly just going to get a bunch of people taking it, but only the people that actually care about taking it. So again, a very biased form of sampling, volunteer sampling. Same scenario, it says you use the roles from each homeroom class. This would be kind of like our 4th period class. So you use the rosters from every Titan Academy class. You put all the names from one class into the bowl, and you draw 2 names from the class. So if they came into my 4th period and they looked at my entire roster and they randomly selected 2 names. It says you go through each homeroom class drawing 2 names from each class. So then you go to Miss Huber's room and you randomly select 2 names from her roster. And then you go to Miss Audette's room and you randomly select 2 names from her roster, etc., etc., etc. And you ask those students to respond to your survey. So again, here's all the different types. This one would be an example of stratified sampling. Stratified sampling. The reason this is an example of stratified sampling is because the population is divided into groups based on homeroom or based on 4th period Titan Academy class. And then from there, they're randomly selecting people from each group. So some from mine, some from Miss Huber's, some from Miss Audette's, etc., etc. That's called stratified sampling. Same scenario, you're in charge of school activities. It says you stand in the cafeteria during your lunch break and you ask students that should be an if they would be willing to participate in your survey as they walk by. Again, this is a biased form of sampling, probably not the best form in the world. So if we look at all of our different examples, this is called convenience sampling. Convenience sampling. So the reason is because it's convenient for the people that are walking by you at lunch to take your survey. If somebody doesn't come by the cafeteria at lunch, obviously there's no chance they would take your survey if you're not moving around and you're not randomly selecting people for your survey. So convenience sampling, because it's convenient for you. Same scenario again. It says you decide to put the name of each student in the school into a big bowl, and you draw 100 names and ask those students to respond to a survey about the activities they prefer. So here's a picture of all the different types of samplings. So this one is the one where you're looking at every single student in the entire school and you're randomly choosing names from every single student. So this is an example of simple random sampling. So it's completely random. Remember, this is the one where if your population gets bigger, this might not be the best one because it might be expensive to contact all these people. Somebody might not respond, etc., etc. So even though this is the best type of sampling, it's not always feasible. Simple random. So SRS is a good abbreviation for that if you just want to abbreviate simple random. All right, for this one, you are in charge of school activities. You want to know what they prefer. It says you get the list of all the homeroom classes and randomly select 5 classes. So this is starting to sound like that one a couple slides ago, but let's see how it's a little different. You get the list of all the homeroom classes and you randomly select 5 classes. It says you go to each of the classes selected and survey all. So again, you randomly select 5 classes and you go to all of the students in the class. So here's an example of all of the different types of sampling we have. So the last one we talked about where we went to my room and chose a few students and then went to Miss Huber's room and chose a few students and then went to Miss Audette's room and chose a few students. That was an example of stratified sampling. In this case, we are partitioning the population into smaller groups, but this time we're sampling everybody from one group. So this is an example of this one. It says you go to each of the classes selected and survey all of the students in that class. Would be an example of cluster sampling. So this last one down here. So you've still partitioned the group, but then you're asking everyone from that group to participate in your sample. You want to say hi, Max?
Hi.
All right, we got a couple more. Number 7, you are interested in finding out the percent of residents in the city that have experienced a robbery in the past year. Using the city property records, you assign each residence a number. It says you use a random number generator to give you a list of numbers. You contact the residence that corresponds to that number to ask your questions. Can you answer that? Sorry, my dog wants to go to the bathroom. Oh, and here comes my son. Wait for it. There we go. Stop. I'm trying to record my video. So here are all my examples. Again, this is completely random. You use a list of everyone that lives in the city. Go down that way. Thank you. You will use a list of everybody that lives in the city and randomly choose a bunch of different people from the group. This is called simple random sampling. So again, this might be a little harder because everyone in a city would be a lot of people. It might be hard to get information back from all of them. So it is the best form of the survey as long as everyone wants to participate in your survey. Simple random. All right, here's the last one we're going to do together, and then there's some for you guys to try on your own. Give me just a few more minutes and I'll be done, okay?
Okay.
Thank you. It says a restaurant owner wants to find out the average number of dishes ordered at each table served on Friday evenings, their busiest time. She decides to collect and analyze every 5th receipt of the night, starting at 6 p.m. So here's all our different types. This is an example of systematic sampling. So at 6 p.m. she starts collecting every 5th receipt. So the 5th one, and then the 10th one, and then the 15th one. So that's an example of this whole idea of systematic sampling. All right, the last thing I want you guys to look at today is this. I want you to try and read these and using those 6 different types of sampling, see if you can classify them. So we'll do one at a time and I'll talk about each one. And then I'll show you all the answers at the end. So go ahead and think about these as you're looking at them. So for number 9, it says each student at a school has a student identification number. Counselors have a computer generate 50 random identification numbers, and those students are asked to take a survey. What type of sampling would that be? It should be SRS, the random sampling, simplified random sampling. So if you have a list of every student in the school and you're randomly choosing 50 of them, that's random sampling, SRS. Let's look at number 10. A principal orders t-shirts and wants to check some of them to make sure they were printed properly. She randomly selects 2 of the 10 boxes of shirts and checks every shirt in those 2 boxes. What type of sampling is that? All right, so the shirts have been divided based on the different boxes that they're in. So I'm thinking it's either stratified or cluster. So remember, stratified would be if they choose a few shirts from each box, and cluster would be if they check every shirt in a couple boxes. So if you read it carefully, it says she randomly selects 2 of the 10 boxes of shirts and checks every shirt in those 2 boxes. So that is an example of cluster sampling. So we've divided the 10 boxes and we're going to take 2 of them and check all of the shirts in those 2 boxes. Let's look at number 11. A school chooses 3 randomly selected athletes from each of its sports teams to participate in a survey about athletics about the school. What type of sampling is that? All right, so we have divided the athletes by sports team. So again, probably either stratified or cluster. Notice that they ask each sports team to have a few people respond to the survey. They randomly choose a few people from each sports team to respond to the survey. So that's an example of stratified. So put them into groups and then take a few people from each group. And last one, number 12. While students are lined up for school pictures, a teacher passes out a survey to every 10th student. To every 10th student. What type of sampling is that? All right, so we are numbering them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you take a survey. 11, 12, 13, 14, 15, 16, 17, and 20, you take a survey. So every 10th student, that is an example of systematic sampling. Systematic sampling. All right, so let me move these so you guys can see that. Simple random, cluster, stratified, and systematic. All right, good. That's it for today.